Okay, so for this one, the first part's pretty simple. We know the amount of the profit is $32,784. The difficult part of this, and it's not too bad, is how do you express the sales revenue? Well, the sales revenue is the cost per item, or the price per item, times the number sold. How much do they charge for them? $9. So it's 9 times something. How many are sold? That's what we're looking for, right? So that's X, exactly. So 9X minus total cost. What's total cost going to be? Well, the cost times the number sold, right? So $6 each times 6. Then what? Combine 9X minus 6X is 3X. And then perfect. Divide 3 by 3. So X equals perfect. 10,928 pieces. What do you think? Not horrible? Better than a sharp stick in the eye? So far? Okay. Yeah. A lot of people overthink that one. Yeah. Well, to be honest, you bring up a very good point here. Looking at this, wouldn't it just be easier to say, hey, 9 minus 6 is $3 each and divide by 3? And that's the problem with some of these simpler problems when we're doing word problems and trying to put them into equations. Is some of the simpler ones, you can just look at them and you can see how to figure out the answer. So then forcing yourself to step back and trying to write an equation for them can be difficult. I mean, sometimes the more difficult problems are easier to write an equation for because you don't know the answer, so you have no choice but to start writing it out. Once you know the answer, it's really hard to force yourself to step back and do this. And I get that. I mean, I'm the same way. I would never have written an equation for this if I was solving it on my own. I would have done just that. I said 9 minus 6 is 3. Divide by 3, there it is. Unfortunately, we're trying to use simple problems to help you write an equation, and they can get confusing. So yeah, my math lab is going to, in many cases, ask you to write an equation. But if it doesn't ask you to write an equation and you just can figure out the answer without it, I have no problem with that. And on a test, I'm never going to say, what is the equation for this first? Just, hey, solve this. What is the answer going to be? You can always guess in checking. I mean, you just guess numbers and put them in and see what works, too, if you have to. So anyway, the next step, we've started talking about the geometry with the angles and stuff. We talked about areas a little bit in the first hour of class as well. If I have a rectangle has 2 dimensions. It has a length and it has a width. We are going to refer to the length as L, the width as W. We talked a little bit in the last unit about perimeter. Perimeter P is equal to 2 times L plus 2 times W. We mentioned in the first hour of class, area. So A for area is equal to length times width, L times W. With these formulas, first of all, if I give you a rectangle that is 5 inches by 11 inches, we can find the perimeter. Perimeter is going to be 2 times 11 plus 2 times 5. Order of operations is all we have left to do. 2 times 11 is 22. 2 times 5 is 10. We had to get 32 as our perimeter. We could find the area of this. The area is going to be what? 11 inches times 5 inches. 11 times 5 is 55. And I'm not going to be picky about the units right now, but inches times inches would be inches squared. This, of course, would be just inches here because we were adding those. Well, that going that direction isn't terribly interesting. It's more interesting when we look at something like this. A rectangle has an area of 72 inches squared and width of 6 inches. Find the length. So my formula for the area of a rectangle is area equals L times W. What do I know? Okay, W is 6. Do I know L? Nope, looking for the length. Do I know the area? 72. Yeah, I better know the area because I can only have one unknown, right? So now how do I solve this? Yeah, L is multiplied by 6, so I'm going to divide by 6. 72 divided by 6 is 12, so my length is 12. To be accurate, I should go back and find the units in the problem. That is 12 inches. Let's say we're told a rectangle has a perimeter of 320 meters. If the length is 4 times the width, find the length and the width. I like to draw out pictures for these. I've got a rectangle. This is my length. This is my width. Perimeter is 2 times the length plus 2 times the width. Do I know the perimeter? Yes, 320. But I don't know the length or the width. And I cannot have two variables in my equation. So there's got to be a relationship between them, which is the length is 4 times the width. So the length is 4 times W, 4 times the width, like that. So now, when I come here, I'm going to replace L with 4W. So 2 times L becomes 2 times 4W, plus that is still 2W. Now I do have to combine what I can here. My first step would be 2 times 4W is 8W. Any questions so far? Because I can't. Remember, when order of operations says you have to multiply before you add. So this 4W is being multiplied by 2. So I have to do that before I can add the 2W to it. Now I can combine the like terms. So 8W and 2W make 10W. Divide by 10. 32 equals W. All done, right? Say no. No, why not? We have to find the length. Yeah, W is 32. The length is 4W, so 4 times 32, which is 128. If I put that back in the formula, I can always double check to make sure I get my 320 meters, and I will. Find the area of this in your notes for me quick. Area is just length times width, so it'll be 11 feet times 7 feet, which is 77. Feet times feet would be feet squared or square feet. The reason I asked that again, it looks like I'm taking a step back in difficulty. Just trying to get a run at it for something like this. Let's say this is 24 inches. 18 inches, 9 inches, and 12 inches. I want to find the area of this. Well, the only thing we have found the area of is a rectangle. So I have to divide this into rectangles. I could probably cut it across here, or I can cut it across there. Doesn't matter to me. Anybody have a preference? Cut it this way. So now I have 2 rectangles. I find the area of the 2 rectangles and I add them together, I'll get the whole piece. So what's the area of rectangle number 1 here? What's its dimensions? It's got a length of 24 and a width of 12. So 24 by 12 is 288 inches squared. How about for rectangle number 2? It's got a length of 9. What's its width? 6. Where'd you get 6 from? Perfect. It's 18 inches all the way up here. Has to be the same distance from here to here. If this piece is 12, this piece has to be 6 to add up to 18. Everybody see that? Anybody have questions on where that came from? Okay. So that is 6 inches there. 9 times 6 is 54 inches squared. And that adds up to make 342 inches squared. That is a skill that a lot of people struggle with, is what we did just right here, is finding that missing dimension. Now, we didn't need it for this problem, but you could also have found this dimension here. What would that have to be? That 24 minus 9 would give us 15. Notice that when we're finding a horizontal dimension, we could only use other horizontal dimensions. When we were finding a vertical dimension, we only used other vertical dimensions. First thing I want to do here is I want to find this missing dimension. How would I go about doing that? Well, this one's kind of tricky, but it comes to here. So I know that if I go down and come back up, I have to end up at 0, don't I? Does that make sense? So I'm going to start off of this line here, and I'm going to go down to the bottom of the figure, then work my way back up. Basically, I'm going to say is how far am I at every point from that line? So if I start right here and I go down to here, how far am I below that line right now? 20 inches. That's 20 right there. If I go over here, how far am I below the line? Still 20 inches. Why haven't I moved? Because I've gone horizontally. This is parallel to that. I don't move any further or less or further away. So I'm still at 20 inches here. If I move back up to here, though, I've come up 9. So this is going to be 20 minus 9, or I'm now 11 inches away. If I'm looking at from here to here, that's 11 inches. How far away am I over here? Still 11 inches. That's a horizontal line there. I don't move up or down any, so I stay at 11 inches. If I come down here, how far away am I? 11 plus 4 makes 15. Over here, still 15, right? So, coming up to here, bless you. 15 minus 7 puts me at 8 inches. So over here I must be 8 inches away. So this distance has to be 8 inches. That's what would bring me back to 0. Does that make sense at all? Yeah. It's just finding that right spot. I mean, you could have started down here as well and said 20 inches up, so I got to get to 20 inches going this way. It's just, you're going to pick a reference line and figure out your distance from that line to every horizontal point. If you're finding a vertical dimension, you have to find your distance to every horizontal point of the figure. Now we can do the same to find this one here. If I set a reference line here, I'm at 15. This has to also be 15 because it's parallel to my reference line. Another 28 makes this 43. This is also 43. Where am I at here? 43 minus 8, 35. This is at 35. How about here? 35 minus 14, 21. So this has to be 21 inches here. Get back to 0. I know I went through that second one kind of fast. Any questions? Now the next thing we want to look at is, what if I asked you to find the area of this? I made it all scribbled up. To find the area, we'd have to cut it into pieces somehow. I would probably do, usually what I do is I just take every vertical line or every horizontal line, depending on which way I want to go, and I extend them. This one I'd probably make every vertical line extended like that. So now I have rectangles. What's this first rectangle? 20 by 8. I've got to have 2 perpendicular dimensions. So that's 20 and that's 8. I'm just going to leave the units off here for the sake of time. What's this second rectangle here? I know this is 14. This is 20 minus 9 makes it 11, right? How about this one here? Call that rectangle 3. Might be easiest to find this dimension first. It'll be this dimension. Can anybody see what it is? Careful. 4 is this way. This has to be 6. It's 21 from here to here. This is 15, so 21 minus 15, that piece has to be 6. How about this dimension from here to here? 7 plus 8 makes it 15. That's 90. Then this last piece here, 7 times 15, right? Those are given for us. 105. So 509 inches squared if you wanted to add them all up. Now this one's a little complex for just starting out. We'll work into it a little more slowly than that, but some of the homework you might get problems close to that, not quite that bad. This is one of those concepts that we usually have to visit a few times. The hard part is not finding its areas. The hard part is, one, seeing how to divide it up or deciding how to divide it up, and then two, making sure you have the dimensions for some of those rectangles. I'm looking around the room and I'm seeing a glazed look on a lot of faces. So I'm thinking it's time to call her a night. We've covered pretty much everything we need to anyway. So there is a new homework that is due for Thursday. There is no quiz tonight because we didn't have a homework due tonight. Also, make sure you are looking at those tests and trying to figure out what you did wrong. Those corrections are not, you have a couple weeks to do corrections if you want to, so they don't have to be done on Thursday. I just want you to look at them and try to figure them out first before you ask me questions on them on Thursday. Oh, sure. Like I said, you can work with your friends if you want to, work with me, ask another teacher, whoever you want to work with. Just make sure you get them figured out right and get them turned back in so you can get your points back. Hey, just have a good night.